Hey, welcome back, students. In this video, we're going to do the study guide for the Module 8 test. For any of you that are not in my class and you stumbled onto this video because of description or whatever, we're going to cover this chapter, or this module was triangle similarity. We also touched on dilation a little bit. So we're going to start here, just number 1. All right, so fill in the blanks using the available answer choices. Use the figure to complete the statement. So we got two figures here. All right, it says transformation from. Now I want to point something out. From is a key word that tells us this is the old. All right, from triangle JKLM. To is, almost wrote old again. To is our new. NOPQ is a blank. So we got some blank. We got enlargement or reduction, and with a scale factor of blank. So old to new. So is this? So did we get bigger or did we get smaller? Obviously, this is bigger. Even though if you've watched me before or if you're in my class, you know that we don't make assumptions. But this is the only time I let you. This is bigger than this. Bigger, also enlargement, same thing. So it is an enlargement. Now, how do we know this and how do we get the scale factor? So the scale factor, I'll just write this here. Scale factor, also known as K, is the new divided by the old. So here, and we're going to use corresponding sides. So JK and NO are our corresponding sides. So our new is 24, and our old is 3. So 24 divided by 3 is 8. So of course we have a bank down here, and we'll scratch them out, but I would rather just talk about how to do this. So 8 is our scale factor. We'll plug that in. See, that was one of our choices. See, reduction or enlargement. But so as far as scale factor, we learned in this module that if K is less than 1, that it is in reduction. And think about fractions and decimals. And if K is greater than 1, it is an enlargement. And because you're multiplying you multiply the scale factor to get your figure. So if you multiply, say, less than 1, we'll say half. So if you multiplied 5 times a half, you would get 2.5. That's a smaller number. But let's say if it's 5 times 5, well, that's 25. So it's a bigger number. So think of it in the same terms. Okay. Scooching up the page here. Number 2. All right, number 2. So triangle ABC has vertices, and it gives us those coordinates. All right, so a dilation with center at 0, 0. So this is the origin. So that means we don't have to do anything special. It maps ABC onto A prime, B prime, C prime with a scale factor of 2. So K equals 2. And they want the new coordinates. So this was printed, the test or the assignment, the online assignment, you would drag and drop whichever was correct. But so for this, it's X comma Y is going to be KX comma KY. So we're just multiplying an X by K and then a Y by K. And then we put the new numbers there. So I'm going to do A over here, but the rest of them I'm going to point. So we'll just say A. So A is 0, 2, and our scale factor is 2. So 0 times 2, and then 2 times 2. So 0 times anything is 0. 2 times 2 is 4. So up here for A prime, it would be 0, 4. So this is just step by step what I'm going to point at now. All right, so B, the x coordinate is 4. 4 times 2 is 8. Now the y. Y is 6. 6 times 2 is 12. Now we go to C. 8 times 2 is 16. 4 times 2 is 8. Easy peasy. This is how, if you want to write it out, but if you just want to, you would go 0 times 2 is 0. 2 times 2 is 4. That easy. So now, if you want to circle these, I mean, these are the answers, but I like to kind of look over here and make sure I have them matching up. 0, 4 right here, and then 8, 12 here. Okay, number 3. A dilation centered at the origin maps point 3, 6 to point 5/4, 5/2. What is the scale factor? All right, so scale factor, or K, is new over old. So we're going here to here. So this is your old, this is your new, and we're going to do, we'll divide the X, we'll divide the Y. Let me just scoot down just a little. All right, so for X, for Y, so new over old. So new 5/4 divided by 3, which is the same as 5/4 times 1/3. As we go back to elementary math, and when we divide a fraction, when you're dividing fractions, you multiply the reciprocal. So we just flip that over. All right, so 5 times 1 is 5 over 4 times 3 is 12. And actually, these should match up. All right, 6. All right, well, that's the old is 6. The new is 5/2. Whoops. 5/2 divided by 6, which is the same as 5/2 times 1/6. Again, reciprocal. 5 times 1 is 5. 6 times 2 is 12. So your answer here, 5/12, or if you divide 5 divided by 12, it would be 0. It's 4.167. We would say 0.42. I would accept both of those as correct. All right, let's flip over. So, and I'll apologize ahead of time for a couple of typos that I didn't discover until obviously too late. And, double bad on me because I knew the typos from when I did this, but didn't print it before the video. So, blame my production team. Unfortunately, that's me. So number 4. A dilation maps rectangle, or STU, onto R prime, S prime, T prime, U prime. So it doesn't say from and to, but anytime you have this prime, this is where you start, this is where you go. This is your old, this is your new. This is your old, old, this is your new. And for the scale factor, or similarity ratio, same thing, it is new over old. And of course we corresponding sides. So new over old would be 2/8, which reduces to 1/4. Or if you look at SR, so 1.5/6 also reduces to 1/4. And that matches up with number C here. Number C, listen at me. Problem with the math teacher. But that's our similarity ratio. All right, scooching up. All right, number 5. So quadrilateral ZXYW is similar to quadrilateral ABCD. The ABCD's down here. And here's one of our typos, i.e. these letters got over here. Don't know how. They have nothing to do with it. So it says place the vertices of quadrilateral Z, X, Y, W in order based on their angle measure from least to greatest. Okay, so you're like, well, this is A, B, C, D. Let me show you the trick. So in geometry, so they wrote it like this, A, B, C, D. They wrote it Z, X, Y, W. So you write it just under Z, X, Y, W. And they match up. So Z and A and Z, B and X, C and Y, D and W. You want to draw lines, try to do that without making it look bad. Well, too late. I also like to do this. So A goes with Z. I'm going to write a big Z right there. B goes with X. I'm going to write an X there. C goes with Y. I'll write a Y there. And D goes with W. There is my W. So this is now quadrilateral Z, X, Y, W. So give them the angle measures from least to greatest. So least is 75. So you would start with X. Excuse me one second. Okay. Excuse me. And then next would be 85, which is Z. All right. This is next, 95, Y. And then the largest, 105, is W. Easy peasy, right? All right, flip over. Now's a good time to say, yes, Mr. Whitlock, we can tell you have younger kids because you say things like easy peasy. Yeah, sorry. All right, page 3, number 6 at the top. And that's gonna, I'm just gonna go ahead and point, make sure. Yeah, so you can see here's 6 and here's 8, so there's no 7. So that's typo number 2. Sorry about that. These, I have a hard time with Microsoft Word. I apologize. I'm not saying I make all these, but I'm just saying that I have a hard time correcting stuff, so that's part of the issue. Anyway, back to learning. Number 6, fill in the blanks using the available answer choices. So in the figure, triangle ABC can be mapped onto triangle FDE by using a series of dilations and rigid motion. Complete the statement about the triangles. Okay, so before we even look at this, let's look at our triangles. So we have a box. By this time, I hope we know that box means that that's a right angle, and that is a right angle is 90 degrees. Okay, same thing here. And we also know that a triangle equals 180. I hope we know this by now. So 180 minus 90 means that the other two angles together equal 90. So we're going to just check to see, or if you look, so 54 plus 36 equals 90. I've been doing it the long way, but if you subtract it, excuse me, 90 minus 36 is 54. 90 minus 54 is, guess what, 36. So that means these angles are all the same. You know, they're congruent. They have 3 congruent angles. Now, also remember we talked about, as far as similarity, or when we were talking in the last module, congruence, it's because it's a right triangle. This guy he's a right triangle, so we don't really talk about the right angle anymore. So it's angle. A lot of folks get caught up. It is 3 angles, but it's almost like the right angle is silent because it's a right triangle. That's the best way I can do it. So they would be similar by angle similarity. See, I haven't even read the problem, but we got this from here. But let's read it before. Let me write this in, then I'll read. So, because dilations and rigid motions preserve, your choices are side length or angle measure. Well, I hope by now we've talked about angles enough that, remember, a triangle, the angles stay the same. It just may get bigger or smaller, but the angles, and that's where preserve comes in. They stay the same. So preserve means to stay the same, and those are angle measures. All right. And then, of course, here, and notice, so this has S and this has an S. There's no talk about sides, so you could really come down here and be like, nope, nope, and that would have left this guy. So just little tricks. So no number 7. Number 8. And this one, I'm going to do my best because I had a hard time with this problem probably both of the last 2 years because my brain wanted to solve it one way. So I've gotten better at explaining it. Hopefully you guys will agree. So number 8, Jeremy stands so that his shadow and the shadow cast by the flagpole end at the same point. All right, very important. That means, so here's the flagpole. Its shadow goes all the way to here. Jeremy's goes from here to here. So when we're setting up our ratio, this is Jeremy, this is his shadow, this is the flagpole. Its shadow goes this plus this. Everybody wants to put it as this, so just watch this. And that's enough of this. So if Jeremy is exactly 74 inches tall, so let's just put a 74 beside Jeremy. What is the height of the flagpole in feet? All right, so we're going to call it X because why not? That's what I call everything. But no, seriously. So here's our variable. This is what we're looking for. All right, a couple of issues. So Jeremy is in inches. This is feet. This is feet, and they want it in feet. So what we're going to have to do is turn these into inches so we can solve for X, and then we're going to convert it back to feet. So how many feet, how many inches are in a feet? A foot. Golly, thank you, I'm not an English teacher. 12 inches equals 1 foot, right? Right. So we're going to say 12 times 8 for this, which is 96. And then over here, 16 feet. So 16 times 12 is 192. So putting these in. So now we're dealing in inches. So our ratio is going to be Jeremy to the flagpole, and then Jeremy's shadow to the flagpole's shadow. All right. So Jeremy, he's 74 inches tall. The flagpole is what we're looking for, so it's X. His shadow is 96 inches. The flagpole, its shadow is from here to here, just like we've talked about segment addition. So we're adding these two segments. So 192 plus 96 equals 288. Now we're ready to butterfly or cross multiply, whichever you like. So we're going to have on one side, we'll have 74 times 288. And on the other side, we're going to have X times 96. All right. X times 96 is 96X. 74 times 288 is 21,312. All right, we're solving for X, so let's divide both sides by 96. Divide those out, and you're going to get 222. So X equals 222. We write this here? No. That's 222 inches. Bad math teacher for not putting that in the box, but that's okay. We got there. So how many inches are in a foot? 12. So we have 222 inches divided by 12 inches to a foot. That gives you 18.5 feet. So Jeremy is 74 inches, which is just a hair over. It's like 6.1 feet, 6.1 and some change. And so the flagpole is, 3 times his height, or almost. All right, let's flip over. Okay. make it so you can see it, but I want to make sure everything fits in the frame, I guess. Okay. So match the reasons to each statement to complete the proof. So we've got a little word bank. They put the blanks here and they put them here. You can write them in either place. I'm just going to do it here because I like having it across from the statement. So our given is that angle HGI and HFJ are congruent. So let's just color these guys in. All right. And they're wanting to prove that these two triangles are similar. And you see it's one on top of the other, so they're obviously different. You look down here just before we look at this. So we've got transitive property, we got third angle theorem, reflexive, given, and then angle similarity. Well, we're doing similarity, not congruence. So, well, that doesn't necessarily mean we won't use those, but we're going to go here. We just got to find that other angle. So we have an angle, we need a second one. All right, so statement 1. Angle HGI is congruent to HFJ. Well, that was our given. That is our given. And lucky for us, given is one of the options. Okay. Number 2 says angle GHI and angle FHJ are congruent. So, a couple of things. Hold on. Number 1, so the middle letter. The middle letter is always the vertice. Notice those are the same letter. Why? Because it's the same angle. It just has a different name because it belongs to both triangles. So angle GHI belongs here and FHJ belongs to that one. But it's the same angle, and I forgot I'm sitting here doing that and meant to, whoop. So, all right, so now we have our angle. So we know what number 3 is, but what's our reasoning? All right, is it transitive? Well, transitive is talking about 3 different things being congruent. Like A is congruent to B, B is congruent to C, so A is congruent to C. Well, that's not it. Third angles theorem. Well, this is a second angle, so it can't be a third angle. Reflexive. So when you look in the mirror, you see your reflection. When we're talking about the same thing being congruent to itself, and it's usually because it's attached to 2 figures like this, it is the reflexive property. So, all right, and the only thing left, and of course, how are they similar? Because you have an angle and an angle. So angle, similarity. Okay. Scooching down the page, moving right along. Video's longer than I intended. I apologize. I'm a little chatty, you know. All right, number 10. And I'll try to move along a little better. So, is triangle ABC similar to DEF? So ABC, DEF. Explain your reasoning. All right, so before I even look at these guys, so one says no because BC is not equal to EF. Well, when they're similar, they're not going to be equal, so scratch that out. So that leaves a no, a yes because of angle. Well, they have no angle measures, so it's really, and see, this has an angle, so we can really narrow it down to these guys. So how do we figure it out? We're going to see what side, if all 3 sides are in the same proportion. So A goes to D, B goes to E, C goes to F. So AB, first 2 letters, DE. So, and it doesn't matter which way, as long as if this triangle gives you the top, it has to be the top all the way around, because it's going to be this, this, and this. We're going to go left over right. So 3.6 goes with 6. Whoops, 6. 3 goes with 5. Notice I started here, starting here the last time. 4 over 7. All right, so if we divide these out, so 3.6 divided by 6 is 0.6. 3 divided by 5 is also 0.6. So we got 2. But if you divide 4 by 7, you get 0.516, something like that. But so check, and no. So it can't be side, side, side. The only thing left, no, because the corresponding sides are not proportional. And that means it has to be all of them. So the answer is B here. Make sure I didn't skip a side. Okay. Number 11. All right, what reason proves that FHJ is congruent to GIJ? All right, so we got angle. We got side angle side. We got side side side. We got, so I'm just, listen, there is no this or writing it backwards from this. I won't say it, but if you take this backwards, there's none of that or SSA in geometry. Okay, just there's not. So letters FHGI. FHGI, so nothing to compare there. All right, HJ, IJ, HJ, IJ. We'll go smaller over big. Just, it doesn't matter. That's the way I'm going to do it. You could do it the other way, but so it's going to be 3.5 over 7. So it's, let me just say, so H, it would be FH over GI, which were blank, HJ over IJ, which is this, and then JG over JF. So this one is 2.5 over 5. Well, and if you divide 3.5 divided by 7, it's 0.5. 2.5 divided by 5 is also 0.5. So these are, now, so we have two sides, a side and a side. I'm hoping you guys have already, didn't need me to go this far, but it's okay. So get in the habit. I'm going to highlight this right here. Notice J. Notice that those triangles touching make an X. Those are vertical angles. They always like to hide that. So vertical angles are congruent. So that means this side and this side are congruent. It's left to right or up and down. But those are vertical angles. So now you have a side, an angle, and a side. So a side, an angle, and a side. Sorry, it's hard to watch the screen and write over there. All right, number 12. And I apologize, here's typo number 3. So 13 is asking about missing statements and reasons, and it's for the proof on the next page. I don't know why it stuck it up there. I apologize. So, number 12. What is the length of IJ? So, these two are congruent. Let's see. So, here it's going to be HG over GF and HI over IJ. All right, we're looking for IJ. We'll call it X. I mean, we can call it IJ. It doesn't really matter. Actually, you know what? We will call it IJ. So, HG, 2, GF, 1, HI, 2.5, and then IJ is that. Cross multiply. So 2 times IJ is 2IJ. And then 2.5 times 1 is 2.5. Well, we're going to divide both sides by 2. IJ is going to be 1.25. And notice, so 2 is double 1. 2.5 is double 1.25. All right. So the real number 13. So we're going to use the diagram. I'm going to, yeah, that gives us the, well, let's see. Hold on. Let's see where my screen, actually, let me back up one. Yeah, that's fine. So use the diagram given. Point B is the midpoint of AC. So B is the midpoint of here. So, you know, before we even look here, I want you guys to get in the habit of writing what this tells you. So if B is the midpoint of AC, that means this guy, AB, and this guy, BC, are congruent because it's cutting into two equal pieces. All right, and likewise for our second statement that D, excuse me, is the midpoint for CE. So that means that CD and DE are congruent because, again, it's the midpoint. Sorry about the incessant, having to clear my throat. Incessant, excuse me, that's why I'm not an English teacher. All right, so they're only looking for a blank here, a blank here, and a blank here, but we're going to go through this whole proof because the blanks are going to change. The blanks are going to change for different problems, and I want you guys as prepared as possible for this EOC. So they want to prove that ACE is similar to BCD. So we have a side and a side, just looking at what I got. But let's go through here. Statements, all right, number 1, B is the midpoint of AC, D is the midpoint of CD, and that was our given. Makes sense, right? All right, statement 2. AB is equal to BC. Well, look, we already wrote that. Why? Because we just do this up here and it helps us walk it through. C is equal to DE. There you go. And why? Well, because this is the midpoint. We knew this. So it's the definition of a midpoint. All right, so number 3. AB plus BC equals AC. So AB, this piece, plus BC, this piece, equals the whole thing. In class, I like to take my dry erase markers and show how we take them apart and put them together. But this is adding a line segment and a line segment. Same thing over here. CD plus DE equals the whole thing, CE. And that is segment addition. Anytime we're adding a piece of a line to a piece of a line, giving you the whole piece of the whole line, it's segment addition. All right, so number 4, man, these look really similar. Let me draw your eye. So AB plus BC. So that was up here, right? Well, this says AB plus AB. So what's different? This one equals AC. Okay, CD plus DE. This one's CD plus CD. So that is different. So what did we do? Well, we know that AB equals BC. So we can interchange, or we can substitute because we know that. So that's called the substitution property, which for here we're going to write substitution. So we substitute it out. All right, so the next line. So AB plus AB is the same as if we multiplied and made it 2AB. Same thing here. CD plus CD is the same as 2CD, and that's the definition of multiplication because it is. Number 6. All right, so if we divide both sides, so divide both sides by AB over here, you would have AC over AB, 2 equals A. So you're taking away this. Here, 2CD equals CE. Divide by CD, it would be CE over CD. So both of these things equal 2. And that's division because we divided to get here, from here to here. All right, so next step. AB over AC over AB, this guy equals CD over CD, CE over CD. Good Lord, too many letters. So this equals this because they both equal 2. Well, that's transitive. That's it. A equals B, B equals C, then A equals C. Transitive property. Transitive is always 3. Symmetric is 2. All right, so now we've got this. All right, we're blank, and it says reflexive. Well, I hope we remember from earlier, reflexive has to do with something being congruent to itself. Well, notice C belongs to this guy, and it belongs to this guy. And it's going to be congruent to itself through the reflexive property. So let's see, what color? Well, this thing's not working. Hold on. Oh, there it is. So this angle, and what is its name? Well, remember it has a different name for because it belongs to this guy and it belongs to this guy. So it's BCD. So angle BCD is congruent to angle ACE. ACE, because reflexive. I've been joking today. So again, middle letter is the same because the middle letter is the vertex. And I like to joke. I said, yeah, this angle's called Charlie with this one, and he's called Larry here. We don't know what Charlie Larry's up to. Sounds like no good if he changes his name, but it's a different name because he hangs with different people in this triangle and this triangle. So now, how are they similar? We have a side, we have an angle, oops, and we have a side. So side, angle, side, similarity. Okay. Yeah, video's getting longer and longer, and so got to hurry up. But I do want to teach. So find the value of x. So we got two parallel lines. So this is going to be just like we've been doing ratio. So you're going to have this equal to this. And if you start on the left, both of the lefts need to be on top. If you start on the right, both of the rights need to be on top. So follow me. I'm going to start with x. X is going to go on the top, so I'm going to go down here for the other, but it's x over 6, 1.2 over 1.5. Excuse me. Now, we butterfly or we cross multiply. So x and 1.5 is equal to 6 times 1.2. 1.5 times x is 1.5x. 6 times 1.2 is 7.2. All right, now we want x by itself, so 1.5. 1.5. Divide that out, and x is equal to 4.8, which is B. All right, flipping over. Yeah, it's 15. Yeah, so we just got 2 more pages. All right, 15. So I'm going to kind of give you the short version here. Sort of. First off, these are mid-segments, okay? So mid-segments, triangle has 3 sides, so it has 3 mid-segments. This mid-segment goes with this side. Hopefully you can see the highlighter. It's kind of weird looking on the screen, even though it looks normal in person. So, and now this guy here, so he's the mid-segment to this triangle as it faces this way. So it's just how the triangle faces, but it has to be the midpoint of the 2 sides. So these two sides, and then all the way around. My hand only goes so far. And the last one, so this is the mid-segment for this guy. All right, so this to this, this to this, and this guy to this guy. And so, and of course, these are parallel, these are parallel, these are parallel. And inside parallel lines, you know, or when parallel lines hit a transversal, your consecutive angles are are the same. And it's like, so these would be above the parallel, below the transversal. So x ends up over here and over here. And essentially what you got, so you know a triangle is 180. And we have 2 measures. Our other one is just going to be, just subtract them. So 180 minus 42 minus 86 gives us 52, which is D. All right, number 16. All right, MP, so this is an angle bisector. An angle bisector, so this one's ratio, it'll be like if we start here, so left over right, left over right. MP is what we're looking for. So you would say, we would go 18 over 12 equals MP, because MP is on the left, over 8. Cross multiply. So 12 MP is equal to 18 times 8, which is 144. Well, we divide both sides by 12. You'll see that MP is equal to 12. Easy peasy. All right, here, number 17, bottom, same thing we've been doing. The only difference, this time they're just asking for the equation. It says what equation needs to be used to find x. So before we even look down here, now I can tell you x is first on all the choices. So we would start with x. It would be right over left, but it would be, so x goes with 5. You see there on the corresponding side. Okay. And then 2, because this is the altitude, goes with 3. So it's x over 5 equals 2 over 3. All right, so x over 5 is 2 over 5. Nope. Oop, nope. X over 5, 2 over 3. Looks like this is B. Okay. All right, flipping over. Last page. So 18 at the top. 19, it copy pasted really weird. Hang on one second. Hold on. So I'm going to draw the figure. It's pretty easy. There's 2 blanks. One of them's given and one of them something else. And it's kind of an easy process of elimination, but I want you to know how to do it. All right, so in this figure, triangle ABC is similar to DEF if AP and DQ are altitudes. AP is 8, DQ is 10. And DE, so DE's over here, he's 14. They want to know what AB is. So we're going to put a question mark. I'm going to try to quit being that math teacher who's always looking for his X and nobody knows why. Last dad joke of the evening, sorry. So it's going to be altitude to altitude, corresponding side. Doesn't matter where you start. We'll start to the left this time. We'll start with the outside. So altitude 8 over 10. And then, what is that? AB over 14. Cross multiply. 10AB is going to be equal to 8 times 14. Excuse me, gotta skip. Got ahead of my notes. Do this too many times a day. Okay. Yeah, so 10 over 8. All right. Yeah, so 112. Divide both sides by 10 because we want AB by itself. And AB is going to equal 11.2. Right here. All right, let me draw the figure that disappeared. Okay, so our given is that AB is congruent to DE and that BC is congruent to EF. I hope you guys will get to the point soon where you're like, hey, that's an isosceles triangle. Yes, it is. But that's not for now. Anyway, I can dream. All right, and that the measure of angle B is greater than the measure of angle E. So these are our givens, and they want to prove that AC is greater than DF. All right, so we're going to scooch up. All right, so statement 1. This is our given. And you see we have two options. Two options. So given. The other part given. So how do we know that AC is greater than DF? And it's the Hinge theorem. You're like, well, I mean, besides it telling us, how do we know this? Well, think of a door. So, door. You guys know I can't draw very good. So, if a door is closed, it has no angle, and it's touching the door face. Like, let's say this is the door face, this is the door. But when you open a door, it's like an angle. And the wider the door opens, so the bigger the angle, the further the door is from the opening. So larger angle means longer side. Okay? Or shorter or smaller angle means shorter side. Hopefully that makes sense. I'm sorry the video was so long. I hope you got something out of this. My folks that are testing tomorrow, good luck. You folks that'll test after you watch this video, good luck to you. Sorry to keep going. Guys, have a good night.